the outsider for once. Yeah, this is a conversation that I really like having. Basically, just for that one moment where somebody has an aha moment or just one takeaway. That's really all I'm looking for. So if you can find one thing tonight that you can use in your arsenal and your tool set to say, hey, I'm going to think about the way I represent data in my code structures a little differently, then that's a success, and that's great for me to hear. So. Love talking about this stuff. So by all means, let's just kind of keep it an informal conversation. If you have questions, I guess what would be the best way is just to ask questions via the chat. Mark, if you wouldn't mind kind of keeping an eye on that, I'll keep one too. But I don't want to miss any questions if any one comes up. Sharing my screen now. Everybody should be able to see a slide deck. If not, please let me know. But we'll go ahead and get started. So basically, this conversation came about going over engagement after engagement and kind of seeing common anti-patterns within specific code bases. Mark and I work for Improving. We're consultants, so we come in and we get to see a lot of different flavors of code architectures, code designs, design patterns, and whatnot. So it's interesting to see different angles, different perspectives. But some of the things that we're going to talk about today are just kind of things that pop up as common anti-patterns. So we kind of put I guess, anti-patterns greatest hits and put it all together, and that's kind of what made the conversation today. So let's go ahead and start talking about a couple of them. So as a data person, when I first started getting into the data community, pretty much the first rule of thumb, like Data Community 101, it's beaten over your head is, never use select star. It's just expensive. It's lazy. Let the code retrieve exactly what it needs to retrieve and don't ask for anything more. Hey, when we're all doing ad hoc SQL for analysis and stuff like that, SQL select star is perfectly fine. It's lazy, it's quick. You don't want to write out every column for, every specific query if you're just doing something quick and dirty. But if it's a piece of code that we want to promote into production, it is extremely important to make sure that we're being mindful about what we're actually asking SQL Server to return. Along the lines of that, entity framework seems to be another culprit of some bad design patterns when we're talking about selecting only what you really need. There's a lot of instances when you look at entity framework produced queries that they can kind of get a little greedy on what they're asking from the data. Basically, the rule of thumb that we kind of like to use when you're requesting data from SQL Server is, get in, get out as quick as possible. Get the data that you need. And allow those resources to be freed up, especially if you're on like a high transactional system with thousands of users, really putting a lot of usage into the instance that's retrieving all that data. So when you do make those queries, just rule of thumb, always ask yourself, do I really need all of those columns? Always it's good to have a small footprint, keep everything clean, everything lean. Also, the fringe benefits of that is when you ask for just what you need, you kind of minimize the table locks, specific isolation patterns, isolation levels within SQL Server, including the default, issues a table lock to when you retrieve data. So it's another thing to be mindful about if you're having a long, intense query. If you don't need to request all that data at once, request what you need. Now, granted, this is a different case for different scenarios. For example, if you're working on something like an ETL type project where, you're extracting all the data, transforming it, and then loading someplace else, that's a different conversation. What I'm kind of talking about here is mostly kind of app development, stuff that your queries and stored procedures that you're letting an app call to do certain things within your application. Now, a lot of the tips and suggestions in this presentation tonight really isn't going to be a silver bullet for everything. In the data world, we always have the standard answer of it depends, and that's going to get exercised quite frequently tonight. There's going to be scenarios where if you see a specific anti-pattern and you see a suggestion, it might not be the case where that suggestion is going to 100% of the time always be the right solution for that instance. So it's always a question of, step back, take a couple glances at it from the outside and really ask yourself what you're trying to achieve. So let's talk about just basic SQL execution order. If you look online, there are more exhaustive lists than just this top 8, but these are the common SQL expressions that are used, and this is the chronological order in which the SQL engine allows these executions to occur. So for example, the first thing that happens is the server basically targets the table and all the joins that are associated to that to find out where it's starting. And then from that, it goes on and filters from your where condition. If you have group bys, then it does all of that logic as well. Select is somewhere kind of in the middle. And the reason why I chose this as a important slide to talk about, because a lot of times I've seen misconceptions where, oh, well, I'm just going to do a select top 1. That's only 1 record. That should be easy. It should be, fairly cheap. Well, SQL Server has to do a lot of processing before it gets down to that top execution. So just something to be mindful of. I'll show you a couple tips and resources on how you can make sure you're selecting the most efficient query path and query design as well. So one of the most common gotchas, let's call it, is when I see in SQL stored procedures that are running from an application, unnecessary order bys. So for example, if we're either presenting data from the database and promoting it to screen, if we have a default order by, that's sometimes expensive. We might not necessarily need the SQL engine to do that default order when the processing on the app web server is going to be cheaper to execute that decision as well. So be mindful of when we're doing our executions of order by. Another time I've seen it within Procs is when we're trying to insert data into a temporary table or insert data into a specific table and trying to force order there. Just be mindful of that, because if you're querying data out of that table, you can let the UI, whether it's an app server, or whether it's a page, or whether it's like an SSRS reporting application, let that do the ordering. And a lot of times you might not have a default order. Maybe you're presenting the data and letting whoever the end user is select which preference of order they wish to view the data. Maybe it's per column and they get to choose. So that kind of throws a default order out the window anyway. So good rule of thumb there, if you absolutely positively don't have to have the order presented from the server that way, it is a little cheaper to let the app server or the reporting server or whatever the end result is do that ordering for you. Another thing you'll see here, I've got a format in there as well. Doing a lot of really aggressive formatting on the server side can also be expensive. Sometimes it's pretty quick just to force a format in a stored procedure. A lot of times I'll see that when an application database is also simultaneously masquerading as a reporting engine as well. So if we don't have any specific BI models associated to the organization or to the business, and we're just going to slap a couple reporting stored procedures on an application database, if we start overloading those stored procedures with a lot of formatting, a lot of order by, a lot of what I call data acrobatics sometimes, there's a cost to that, not only by the query itself, but what is that doing to contention? Are there any other users that are going to be negatively impacted by the work that's done on a reporting query? So some things to think about. If you see a situation where you've got an application also masquerading as a reporting database, if it's used heavily, that's gonna cause some possible contention, some blocking, some stuff like that. Reports probably taking a long time to render. Maybe that's not the right design pattern. Maybe we need to have a conversation with the business that says, hey, maybe we need more of like a BI layer, so a reporting layer or an analytical layer, so we can kind of do our data analysis, our reporting, all of our slicing and dicing, maybe do that off the application system so we're not really fighting with the end users for the data access and contention and stuff like that. So those are always good things to think about. It's one of those things where, it's not the kiss of death for sure. I mean, if you've got an application, but you only really have one reporting proc and it's used once a week, is that really a problem? But on the flip side, if you've got an application database and you've got 100 reports, 1,000 users, and a lot of those reports are being executed, hundreds of times an hour, you've got a couple of questions there, really. Are those really reports, or are they dashboards? What are you using that data for? But it's also a good conversation to say, hey, is this really where we need to be doing our reporting? So let's talk about joins. Um, this Venn diagram has always been one of my favorite. If you're ever trying to explain how a join works or how a join operates, just do a Google image search for join SQL join Venn diagrams, and you'll get some images that look like this. This paints a really clear picture as to how data is represented on different joins. And as you can see, you've got your common joins, your inner join, your left join. You got a full outer down at the bottom. I think the only one that's missing here is a cross join, which would be a Cartesian product of the data itself. But all the joins are represented here. So if you're trying to think visually of how this data should look, if you've got table A and table B, you can kind of look and see which join you really need to make. From a data perspective, you kind of want to start with a small footprint if it's available. A lot of times it's not, so I completely understand that. And what I mean by that is take, for example, you need to do you need to return some data that really is more of a summary type data in nature, but you're really starting the from join or the from clause right there. You're starting that from like the detail table. So the detail table is a lot more robust than a summary table, like a detail and header table type relationship. So be mindful of what table we're selecting first, and then which tables we need to bring in as joins. Typically, in terms of like code readability and cleanliness, a lot of data people, I can't speak for all of them, but a lot of people can pretty much operate most of the time with just froms and left joins and inner joins. Mixing left joins and right joins and doing a lot of mixture like that, it's not impossible, but on first glance, it might look a little convoluted. So typically when I see something like that, that's, something within an application, I always have to kind of at least raise a red flag and kind of look at it and make sure that it's operating how it needs to operate. When we're joining, it's always best practice to join on indexes because that way the server is able to do an index seek versus a table scan. And the difference between the two is take, for example, a phone book. Everybody likes to use phone book as an example for indexes. But say you've got a join on a specific, page number. So you can go directly to the page number. But if you're joining on something else, like a, like a name, like a common name, then it's got to filter through and read every page. So indexing is key. Also making sure that you're joining on, simplistic logic. A lot of times I'll see really convoluted joins using, functions on joins. And that's not, again, completely out of bounds there, but you just need to ask yourself, are we doing the most efficient join possible? Are we crafting a good data model? We'll get to functions a little later, but just remember, the good rule of thumb for specific functions are when you are using a function in your data set, it is getting called row by row. So definitely something to consider. So this one's always a favorite. Loops and cursors. Every time that there's a huge performance issue where there's a lot of data processing, and you always get the complaint from a client that says, this thing takes 3 hours, this thing takes half a day to run, and we're doing like a financial process, or we're doing like a closeout process for the business. The red flag always goes up like, well, are we iterating over a lot of individual data? So that's one thing that I always look at to see if there are while loops or even cursors in the process, because that's a row by row operation, right? In SQL Server, it's set based by nature. So if you can take a loop out of the equation and replace it with a single set based operation, you just take on a lot of resource off the table and achieve the same function in a lot less time. So you can actually look like a real hero if you're looking at a 3-hour stored procedure and you see that it's iterating the same data over and over and over again, and you turn that into a set based instance, then you can really get a lot of value there. I've got some examples here that I kind of want to show because I really feel strongly about this topic right here. Recursive CTEs. I don't know if anybody's ever heard of that or used that, but this can be a really powerful tool in your toolkit, especially.
Losing your audio a bit, is cutting out.
Can you hear me now?
Yeah, yeah. It was
Everything good?
just
Okay.
a couple instances of 10 to 15 seconds or 10 seconds or so.
Excellent. I will
But
do the TiVo back button about 30 seconds. So when looking at loops and cursors for doing data operations, a good tool to combat that in terms of efficiency is the recursive CTE. If you haven't used a recursive CTE, it's a really powerful item to have in your toolkit. And I'm going to go through some examples, some real simple examples, just so we can kind of get an idea as to what they look like and where they can be used.
Yeah, people are just saying that audio sounds fine, so.
Okay, good deal. So I've actually seen this in the wild. So let's take a look here. This is just a simple SQL statement. What we're doing here is we're declaring a few variables, and we are basically updating a table. But as you can see, we're going through this table update. We're doing it row by row, which you can do that, but it's just not efficient. So this is a real basic example, something that I wouldn't expect any of you guys to have in your code base here, but I have seen it. So the easiest way to convert this loop into a set-based operation is just do a simple update on an inner join. If you're updating a table from the values of another table, you don't necessarily you don't need to do a while loop at all. You can do an update inner join, and that creates this instance right here. If we're talking about 50 different rows, that has to go through and do 50 different transactions, because each one of these operate as a separate transaction. Whereas this right here, the set-based operation, that's one single transaction. It updates those same 50 rows and carries on. So another example is pretty much how a recursive CTE operates. And I'm going to basically build a table here just to kind of show you how a recursive CTE is constructed. So what I'm going to do is I'm going to create a table, and I'm going to populate that table with some employees. So I've got a series of employees. As you can see, they've got an employee ID, the name, title, and then they've also got on the far right, they've got a field for who that manager is. Now we can see the top of the food chain is the CEO. So Ken Sanchez, nobody's higher than Ken, so he is the top of the hierarchy there. But who reports to Ken? So who is manager ID 1? Well, that would be this vice president right here, Brian. Brian reports to Ken. He's the vice president. Does anybody report to Brian? Well, we've got an individual here. We've got the sales manager, and then we've got the marketing manager. And then the sales manager, he has some people that report to him as well. So we can use a recursive CTE to basically build a hierarchy. Now, recursive CTE looks kind of like a self-join, and there's several instances where you can achieve the same result with a self-join. But as your query and as your data specification, as your query logic gets more robust, you'll find that the recursive CTE is the better option. It's easy to read. It's really elegant in the way it's constructed in SQL Server. You've got an anchor member, which right here would be the top of the food chain. This manager ID is null. So we've got manager ID here. So this is going to be the CEO. And then we're just going to recurse through and build a hierarchy. So we've got recursing through and incrementing on the level ID, joining back to manager ID. So when we run this, we can see the original results. And then we can see that through the recursion, we can build a hierarchy. So that's one use case that you can use for recursive CTE. Just one of those things to kind of keep in mind. If you ever hear, I need to build a hierarchy, then that's a good use case. Keep that in mind. You say, hey, maybe I can implement a recursive CTE here. Another example is where we want to take some sort of iterative transaction just completely off the table. I'm going to monitor chat here. I'm a big trivia fan. Does anybody know what Einstein said the most powerful force in the universe is? Anyone? Anyone? Bueller? Okay, I'll just give it to you. It is compound interest. So let's do a simple compound interest example here. I'm going to create a table. It's just going to have 2 fields in it. Real simple. We're just going to complete this really easily. Month ID and end month balance. We're going to insert a single record, and let's take a look and see what that looks like. So we've got month ID of 1, and then we're going to start with $100. Okay. So what we want to do now is just go through several months and have that interest accrue per month. So this obviously isn't any sort of savings account. None of us are that lucky to have that type of situation, but this could be some really sketchy loan. So let's go ahead and do a while loop here. We've got our table. We're going to set the interest at 5%. Let's just run this for 50 months, and we're going to iterate through using a while loop, inserting a new record into account balance to increment each month's end month balance once the interest has accrued. So if we run that, as you can see on the screen, it turned back pretty quick because this is a very simple example. It gave us our 50 records. It gave us our result here. It incremented 5% every month because this is a horrible loan, and we've successfully done the business requirement. The problem is this construct right here, this is an expensive approach to do this. Now, granted, it happened very quick on screen, but what if it didn't? What if this was called within another proc? What if this was a nested loop? What if, this wasn't 50? What if this was 1,000? What if we, really blew this out and maybe this wasn't as simple as an insert statement? Maybe it was doing something else inside of here. Maybe it was doing some really crazy data acrobatics, convoluted logic, what have you. So let's look at the example that would be the set-based operation. So I'm going to comment this back out. So I've got my interest, got my number of months, that's going to be the same. This time I'm going to build that loop within a recursive CTE. I've got my anchor member, that's going to be the first month, and then I'm going to go through and do a recursive situation to where I'm using the variable to do my 50 months, and I'm going to insert that one time. So this is not 50 transactions. This is one transaction. It's set-based. So let's take a look at this and make sure that we get the same results. Make sure that I'm not telling any lies and doing any smoke and mirrors here. And we get the same result. Now, this is an extremely basic example. I wanted to keep it simple just to highlight how these recursive CTEs are built and how they can be used. But on the back end, in terms of transactional resource, this is a set-based operation. It's all happening at one time. It's not going and doing 50 different iterative transactions. So keep in mind, if you see stuff like this out in the wild and you get complaints from your business team that says, hey, this report, this proc, this was running really slow. Maybe it's a situation where it was running fine because you maybe only had a handful of data points, but maybe acquired a new line of business and the data points expanded exponentially because a whole lot of new data came into the system. This would exactly be the use case for converting that off of the loops and going into some sort of set-based transaction. All right, looking next here is scalar functions. One of the favorite acronyms that I like hearing data people refer to is RBAR. At first, I didn't know what they were talking about, but then when they explained it, row by agonizing row. And this is basically a SQL function. These can kind of be a little misleading, and I'll show you why. So we're all familiar with native functions. Those are built efficiently within the engine. Something like getDate, obviously, that's a scalar function. But what I'm talking about is when we've got a lot of logic based on, custom functions. Well, let's take, for example, we've got some sort of business rule calculation that every time the last Friday of the month happens, we need to update all the records, but it needs to take an input and go through a series of calculations and return an output. Well, for however many records that's going to induce, that function is going to be run for every one of those records. So again, it's exponential on the data, so you don't really notice it unless you've got large data sets, then it becomes a real problem. But there are, again, design patterns to combat that. So one thing I want to go over is the execution plan. I don't know if anybody has ever taken the time to utilize that function within SQL Server Management Studio, but that is a pretty good tool to have in your toolkit if you're an application developer and you're able to open up the execution plan and actually read it and see how the query is being constructed. That will make you so much a way better data developer in the end. So let's take a look at an example here. So I've got two queries. And I'm going to change my VentureWorks database. And I've got a get stock function. Basically, it's going to input the product ID and return how much stock I have currently. So if we run that, and you'll notice I've got a couple lines up here. I'll explain those in a minute. I get my results. It comes back as a column, but the key here is this function just got called 504 times because that's how many records I have in the system. Okay. Now up at the top, I did set statistics IO on and set statistics time on. This is a great tool that's built into SSMS and the SQL engine to be able to show you the resource usage per query. So you'll notice over here on the tab, I've got some data. So you can see the elapsed time here was 99 milliseconds. Simple example. That doesn't look like it's a big expensive query, but I'm keeping it simple for a reason. You kind of have to imagine, we're using 1 million record data sets here. Obviously, the more data, the exponential resources it consumes. Versus something called a tabled valued function. Now, this is a function, just like a scalar function, but it's called a different way. You can actually join on them. You can cross-apply them. So we're going to operate the same query written a different way, getting the same result, just with a different design pattern. So I don't have a scalar function here. I've got a tabled valued function, and it's passing in the product ID, but it's doing it in a set-based manner. Okay? Actually, I missed something here. I'm going to run this one again because I want to show you what that execution plan looks like. Up at the top on the toolbar, there's a little icon up here that says include actual execution plan. So if I want to see what a graphical representation is for this query, I'm going to click that button right there, and I'm going to run this again. So now I've got another tab over here next to messages. This time it took 131 milliseconds, which is still nominal. But let's look at this tab right here, execution plan. We can see here that this is the graphical representation of the query. Now, the misleading part right here is that we've got this compute scalar icon right here, which indicates the scalar function. It's showing 0%. So it's kind of misleading in the fact that it's like, well, it doesn't cost anything. It's 0%. I'm good. But it's just the nature of scalar functions. They're not able to be read by the query execution plan. It's not able to dive into them and get a calculated plan with what's underneath the covers. So it just kind of gives up and says 0%. Another misconception here is that if you've got like an 8-core server, you really can't run scalar functions in a parallel process. They pretty much go down to 1 core, so it's limiting in that fact too. Again, not a major concern if you're dealing with small amounts of data, but if you do see a scalar function out in the wild that's iterating over a large data set, and and you're getting complaints on performance, then this would be a situation where you could say this might be a candidate for a table valued function. So let's just run the other version so we can see that we do get the same results, just different design pattern on the query. And if we look at the messages down here, this one actually ran a little bit longer, so it's not a very good test case. You just have to trust me on that one. In a large, like, million record count situation, this would definitely run a lot quicker. Maybe if I did the query plan cache, does it get quicker? Same. Yeah. Probably need to have a lot more records here to show that better. But as far as design patterns go, table valued functions, you get a little bit more resource benefit versus a scalar function.
Got a question about how does it impact the reads?
How does it impact the reads? Which one? The scalar function, the table valued function, or both? Going into both, I guess it depends more on the indexing. So if you didn't have a proper index on the table and it had to read more records that way, that could be a problem. If your indexing strategy included a covering index to where all of these were on a non-clustered index versus not, your read count would be much lower. But as far as reads, that's a good question. I don't straight up without indexing involved, I don't know that there'd be that much of a difference. Good question. I have to check that out. But typically, if you're looking for reads, that's kind of where a good indexing strategy comes in, and we'll talk about that here a little bit too. Another weird thing that I see in the wild is an inline subquery. Again, it acts like a function. It's row by agonizing row. So what does that look like? Sure, you've all seen them. So I've got a query that looks something like this. The only reason I can think this is done is if somebody just needed a very quick solution and didn't want to go through the work of identifying what the join conditions were. That's really the only thing I can think of here. But if you look at this construct, it's going to fire this query off for every row in the table. So it's a lot quicker just to do the work, get the inner join definition down, and just join that record in so you have it. But a lot of times, if you've got a lot of developers and very large reporting procs that have been touched by a lot of different people, and maybe the business needs a change absolutely positively right now. Obviously, yeah, that's quicker to implement, but not better. So food for thought. If you do see that in the wild, it's a candidate for a join condition. Another one that can be kind of a misconception is when I see the differences between union and union all. Conversationally, a lot of people will say, oh, yeah, we need to union those two data sets. But really what they mean technically is we need to union all of those two data sets. So there is a difference in SQL Server. And if you don't know, it's great to be able to identify what those two are. So when you do just a union, so you've got a select from table A, and then you're doing a union on a select table B, it's doing a lot of work because that union without the union all, that's reading distinct values only. So it's doing the work of, matching up the data and then doing unique sets. Whereas a union all, it just brings all the data in without having to match the distincts. Now, this is a prime example of, it depends on, this is absolutely not a silver bullet solution because the business rules might dictate, hey, those values have to be distinct. I don't want to see multiple of the same value. So, be mindful of what the business rule is when you're crafting up your data sets. But a lot of times I'll see unions in place where a union all would benefit. And a lot of times the data model supports that those are going to be naturally distinct values anyway. So that's a good question to have, when you're analyzing something like that. Say, will this data ever show multiple values? If it doesn't, then we're just going to do a union all, and the distinct measures will come back just by the nature of the data model. So something to think about. Search arguments. This one's a really good popular one because I've fallen victim to it myself. Basically, this is writing queries quick without keeping in mind what the index supports. When you hear something that's, write your queries so that they're searchable. So what does searchable mean? Search argumentable. So queries that are capable of utilizing an index. And I've got an example here. Basically, what we're trying to avoid are table scans. So I've got two queries right here, and I'm going to turn on my execution plan. Make sure I connect to the right database. And I've got two queries. Now, mind you, these are two different queries. These are going to turn two different sets of results. But I've seen situations where people really are coding this expecting the same result when they really don't need to have this bottom one. So take, for example, we've got a business use case where we need to return all last names that are like Ander something, Anderson, Anderton, what have you. So last name like Ander. Now, the bottom query is going to do a lot more than that because we've got the wildcard right before what we're looking to start with. So this is going to pick up more than Anderson and Anderton. This could pick up Granderson or anything else that supports the text before ANDER. So let's take a look at these two in the execution plan. Two queries. I've run them both in the batch. The top query is 3% of the batch. The bottom query is a lot more expensive, and it's at 97% of the batch run. Now, the reason for that is right here. This is doing an index scan. That's reading the entire table. It's not actually opening up the phone book and pinpointing starting from ANDER. It's not doing an index seek. So two different queries, providing two different results. Maybe the developer didn't know they would have two different defaults. Maybe it was just some naive coding, but definitely two different forms of performance here. When all possible, make your queries utilize already built-in indexes. And this is always a good conversation to have with your DBA as well when you're crafting new queries. Index strategy is really an art. There's a lot of trials and tribulations that you have to do to craft queries and making sure that indexes work right, because when you do your index maintenance and your index strategies, you need to make sure that you're not pinching yourself in performance by putting too many indexes on. I've seen that too, where we'll do a query here and find out, oh, well, it's doing an index scan. We just need to add an index for that. And then over time, we've got index bloat. Too many indexes, that's a bad thing. You want the right amount of indexes, and that's kind of where the art comes in. You can have one index that does the work of multiple queries, and that's the real benefit. Those are called covering indexes and covering queries. So if you can kind of look at your query library or your index library, your index estate, and you might find situations where you've got maybe just some misaligned indexes. Maybe you've got 3 indexes that really should just be 1. So great conversation to have a DBA involved, or at least somebody that's got some experience with writing indexes. It's a great thing if you're a developer to have index knowledge under your belt, because that's a very performant tool to have when you're developing data solutions. Let's do another one that's probably a little bit more real world. For example, I've got sales order header records that I want to see, but I only want to see records from 2011. So there's 2 ways of doing that. Right off the bat, you're looking at this and say, well, yep, that's doing exactly what I'm telling it to do. But if we look at it from an index perspective, well, it's operating on a function on a date field. So that means this function has to bust apart that date to parse out the year for every date. So that's kind of expensive. Whereas if we just do sort of like a between, do an order date that's in between the bounds of all 2011 dates, that's going to be an index seek, because if our order date column is indexed appropriately, then it'll just be able to target just those right records that it's looking for. So let's run both of these as well with the index or the execution plan running. And we'll see two queries operating with the same results. And the first one is the index scan. That's 93% of the workload. Whereas the bottom query rather, is doing 7% because it's doing an index seek versus an index scan. Make sense? This one's always a fun one. I like to call it stage table abuse. And I see a lot of this when I was talking about earlier, the example of application databases also masquerading as reporting databases. You know, sometimes application databases aren't developed and aren't modeled with a right dimensional or analytical model in mind. So in order to get data represented in a nice tabular form or however the end user needs to see this data presented, sometimes there's going to be a lot of transformation involved on this application data. So, you know, you might have a stored procedure that's acting as a reporting proc that's just got stage table after stage table after stage table. It's bringing in 1 million records, filtering down 10,000 records to present 100 records or something like that. If you've got a long convoluted stored procedure and it is doing a lot of acrobatics, it's a great conversation to say, hey, maybe we need to rethink our data model here. If we're doing the same calculations over and over again, does it make sense to store those values in the database so we don't have to do those calculations over and over and over again? Can we just pull them? Maybe can we have the application write that calculation to the database every time it gets updated? You know, again, it depends. If it's a report that's run once a year, then I guess it's not really an issue then. So it's give and take, right? You just have to find out where the pain points are. You know, one-time analytical reports, that's not a problem. But what I'm looking for here is if we've got a very lengthy proc that's run 1,000 times a day, and it's really bringing the system down to its knees, and it's either a situation where it's doing data model antics, or it's got some, you know, just some weird convoluted code logic, maybe even loops as well, right? I'll have a query at the end in the resources section that shows you those expensive queries. So keep in mind for that as well. Merge statements. So merge statements are basically acting as an upsert, right? You've got an update if it exists, insert if it doesn't exist, maybe even an update, insert, or delete. Based on certain criteria. Well, a merge statement is, you know, part of the T-SQL language, and it's a very elegant way to create an upsert, but it's not a one-stop shop for all those update insert opportunities, and we'll go into why here. So there's definitely a time and a place to utilize a merge statement. The time to use it would be, well, if you're doing some sort of ETL situation, where it's a one-time run. Where it's not a good time to use the merge statement is that, take, for example, an application database again. Maybe you need to have an update or an insert logic component of a stored procedure based on, you know, some business rule within the application. But that stored procedure gets called, you know, 100 times an hour by different users. Well, the problem there is that the merge statement, since it does a really good job of transferring data to and from a target source, it does that with, you know, some longer locks than normal. So you've got a really aggressive merge statement being called 100 times in an hour. You know, you've got the potential that you're blocking other users while, you know, you're trying to do a single merge statement. If your turnaround time, maybe an SLA for a proc, has to be, you know, a certain number of milliseconds, you know, you really got to question whether or not a merge statement is the right tool for that. So let's take a look at what a merge statement looks like if you haven't seen one. So this is the structure of a merge statement here. I like it. It's really an elegant piece of code. You know, you're merging in your target table name. You're using a source table. You've got your joining condition on what matches those two tables together. When it is matched, you can have your update logic here. Maybe it's all the columns, maybe it's a certain set of columns. When it's not matched, we've got our insert logic here that we can do, and you can even delete those records when they're not matched at all. So a lot of logic goes into just this one transaction here, this one-time set-based operation. So it's really elegant. I like the merge statement, but there definitely is a time and a place for it. So if you've got a situation where you've adopted some code that has just merge statement after merge statement, because maybe that's what the data developer thought needed to happen, it's better just to break those up into specific updates and inserts. It's quicker that way. It doesn't hold the lock for that long, and you can get the same achievement out of it. It's more statements, and it kind of is a misconception, because you think, well, if it's more statements, that means it's probably doing more work, right? But for merge statements, this is the better design pattern. So that's something to keep in mind. I see this one a lot too. Table variables. For data professionals, they're not really not many are a big fan, because you think, well, it's a table variable. It's it's just going to be spun up and used just for the life of the proc. It's going to be should be in memory, right? Like all other variables. Well, for table variables, they do utilize the temp DB, so there is that object dependency there. There's some trials and tribulations with table variables. You don't get the right indexing that you would with a normal temporary table, just your hash table. You don't get the column statistics for it. And if you have to go back and do updates to that table variable, those are serialized transactions, which are really slow. So in terms of performance, if you do need to create just temporary tables to use as temporary staging, holding pattern data for downflow analytics, that's fine too. More times than not, temp tables are more performant. So it's definitely something to take a look at if you're seeing a large data set going into table variables through a proc and you're having performance issues. Definitely something to be wary of. Along with tabled variables are also tabled valued parameters. This is also flagged with, there's a time and a place for this. So everybody knows what a regular parameter is. You can create like a regular integer parameter or a date parameter, pass those into a proc. Well, you can also create a data set as a parameter. Those are called TVPs, table valued parameters. Basically creating a type, just like the syntax above shows, and then you can pass that entire data set to a proc. Pros and cons on using those. There's a lot of work that's done under the scenes when you're passing parameters to a proc, table value parameters to a proc. It's using something called the data stream protocol versus just the regular in-memory passing of parameters. A lot of times there's type conversions, and there is a temp DB table created every time it's done as well. Definitely wouldn't recommend it for large data sets because you're overloading the proc with a lot of that data. And the question that I always have to ask is, why is it that we're hopping the data from maybe an application to a proc? Does the data all originate on the database anyway? Or maybe can we send just the seeded parameters in different variables like integers and dates to concoct the data set needed to operate under that stored procedure? So it's something to think about. Really, a good use case to where you would have to use it is if the data cannot originate from the database. I've seen weird situations where table valued parameters were used just as a common default design pattern. Every proc had a table value parameter, but the bad thing about that was that in that instance there was only one record set getting passed per proc, so it kind of defeated the purpose of a set-based parameter. So just something to think about. If you can originate the data in the proc, it might be, in most cases, more efficient to do that versus sending that data in wholesale to the proc itself. All right, so let's talk about some data modeling sucker punches. I think we kind of talked a little bit about indexes already, but covering indexes, that's the key. You want to make sure that all of your queries are able to utilize indexes. We've already seen examples of table scans versus table seeks. There can be too few indexes and there can be too many indexes. The sweet spot is finding what that balance is between writes and reads on the database. So for example, if you've got a table that has 99% of the activity is reading, well, then a lot of indexes isn't going to be a deal breaker. But if your table has more writes than it does reads, there is maintenance to occur every time a record comes in for each one of those indexes. So that's basically how to find that sweet spot, is to find out what the balance is between writes and reads and adjust accordingly. Your DBA is going to have a lot of tools and a lot of philosophies behind that, but if you're able to ask those questions, you'll get a lot of trust and have a friend on the DBA team, which is always nice to have. GUIDs, this can sometimes turn to somewhat of a contentious argument. I get it, GUIDs are what they are. The only place where I really hate to see them in a database is when they're used as the clustered index. If you default a table to have the primary key as a GUID, it's going to write itself to the clustered index. Well, that's a big data footprint, right? A GUID holds a lot more space than a regular integer does. So your index is just going to be that much more conflated. So there's a little bit more of a resource hit every time you need to update that index. If you do need to use GUIDs, I always like to see an integer as the clustered index. And then if you need to index your GUIDs, make sure they're non-clustered index. You just want to kind of make your index footprints small in nature, just for maintenance, and also just to minimize page splits, right? So if a new GUID comes in the middle right here, it has to adjust all these up and down and reorder them. And a lot of times, if your index is full, then it's got to split itself and make a new page for that. So you run the risk of overloading page splits on indexes when you have situations like this. So something to be mindful of. Definitely not the kiss of death. I'm not saying never use GUIDs. Just if you are using them, just be mindful of them. This is a really weird design pattern that I've seen. Using a CSV as a string as part of a data set. Each one of those numeric values within those CSVs represents something. But every time you need to pull that out, now you're parsing a text string to get a value. Anytime you need to parse something to get a value, whether it's saving data as a JSON object or as an XML object, if you're constantly retrieving and parsing that to get that value, it always begs the question, should we just store that value so that we don't have to do the data acrobatics to get that every time we need it? For this specific example here, a key value pair lookup table is a simple solution that rectifies the situation for having to parse that data. It's a simple join at that point. You can just join on the index ID and get the related target value. Easier to use, easier to read, So that's just something weird. I don't expect a lot of people to see that, but I have seen this a couple times that really kind of raised a red flag. Another design pattern isn't really in code nature, but more of naming convention. Sometimes I've seen stored procedures that are developed from a dev team, and they just have the habit of naming it SP as a prefix, SP underscore. Well, there is a cost to that, unfortunately. The SP underscore prefix is reserved for system procedures. So anytime that SP underscore custom procedure is called, SQL Server is going to look through its library of system procedures first to make sure that it's not existing there, and then if it doesn't, roll down to the DBO layer to find the right stored procedure. So just use something else, USP underscore if you need to. And cascading deletes. This is another one that I see. In nature, it sounds amazing. It verifies that data quality is going to be consistent, because if we're deleting something from a parent table, it's going to go down the hierarchy and delete the child records from that. The only problem with that is that you know, it does transfer over a different isolation level, so it's, you know, serializable at that time, so it's a little bit slower transaction, and you're forcing your business logic and your business rules in your table structure, which, you know, there's arguments for and against that as well. But just in terms of performance, I always like to see, you know, these handled, you know, maybe with the app logic or just individual stored procs managed a proper way. You know, it's just more efficient if we don't rely on the delete cascades to manage the data as we're deleting it. If you're deleting records a lot, you know, it might beg the question of, you know, let's just introduce a soft delete. Can we have a column there that just flags it so it's one or zero? So that way nothing really ever gets deleted. We can always go back and have an audit trail. You know, food for thought, definitely a conversation to have when you're, you know, constructing solutions. So I want to kind of go over some resources here that you can kind of keep for your toolkit. These have helped me out, especially when doing performance tuning and looking at procs and getting more efficient solutions. The first thing that we looked at was the set statistics IO on and set statistics time on. Let me go ahead and bring up that web page. I want to show you what this does. This is a great tool that's, you know, a member of the data community built this for use here. And basically, if we take our statistics information right here, we just copy that and then just paste that here. This will parse this into a nice table that if you're doing performance tuning, this is great to add to a Jira ticket or an ADOPS ticket, so you can, you know, show before and after, you know, how much efficiency you're gaining. So this is just a nice tabular way to take those results and make them a lot easier to read. Finding those costly queries. So if you've ever had to do any Googling on specific SQL syntax, you've probably come across Mr. Pinal Dave's blog, SQLauthority.com. This was probably one of my favorite queries off of his blog right here. Basically, you can run this and it tells you, you know, what your 10 most expensive queries are. And you've got different order by here. So you can look as far as what are my most expensive reads, what are the most expensive queries based on time. This one right here is what's my most popular procedure, most popular query, which query is getting called the most. You know, and it probably begs the question, if that one's being called the most, is it expensive? Maybe we need to look at it. So this is a great query to kind of troubleshoot your system, kind of gives you a picture as to, you know, what kind of stored procedures and what kind of queries are getting called over time. Great one to bookmark. Another utility that's really valuable. This is a community-built utility that's housed over on Brent Ozar's site. There's it's a series of procs. It's a family of stored procedures called SP Blitz. SP Blitz is a stored procedure set that will kind of tell you everything you need to know about your SQL Server instance. But there's one proc in that family of procs called SP Blitz Cache. And this gives you immense detail on poorly performing queries. You know, there's some stuff that can tell you about indexes. You know, it gives you detail on queries to say, hey, maybe this one's getting overloaded or maybe this one's parameterized wrong. But it just gives you a lot of instant detail on queries you might not even know are getting called. So great tool to use. Real easy to understand. Check out that website. Brent's got some great videos on how to use those tools, and you know, you'll be easily on your way to helping make your code base and your server more efficient by using that. This is a simple query that I always like to use if I'm looking for specific design patterns like merges or loops. You can easily just hit your sys procedures table with a search term, and it'll tell you all the procs that come back that utilize something like that. Now, the only problem there is if it's commented out, it'll still bring it back, but at least gives you some identity as to what procs are using what patterns. So good little tool there to use. Those are pretty much the top 3 tools that I would recommend starting out if you just want to kind of get a glance as to what expensive queries exist in your ecosystem. And that does it. Any questions, concerns, comments?
Thank you, Preston. Just kind of one comment on what you talked about with the performance and statistics. So SQL Server has the concept of hot reads and cold reads, right? So one of the tips I came across was to make sure that you test both cold reads and hot reads so that you can normalize your results. And so using the dbc drop clean buffers command to clear out the buffer so that you're pulling all your data from disk initially and then collect those results. And then once you have those results in the buffer, execute the query again and then collect those results so that you know how much a cold load of the data or what the performance hit for a cold load versus a hot load is.
Great tool. The only caveat there is I would suggest using that in dev first. You don't want to do that in prod because that will affect the prop cache. So if you do have a lot of those warm or hot reads on really specific queries that are called a lot of times, and perhaps maybe the cold read takes a long time to spin up. But yeah, you're absolutely right. It gives you kind of good metrics around what that query takes running cold versus what it takes once it's in the prop cache. Just be careful of when you do that.
Gotcha. Thanks.
Mm-hmm. Let's see, Mr. Rootsick, thoughts on sequential GUID use? So yeah, those are not a deal breaker either. That will give you a sequential nature for GUIDs. It just depends on what the requirement is. I've suggested that in some of my prior engagements, and it was funny. The absolute anonymity of the GUID was a requirement over it being sequential. So yeah, if you don't have to worry about the complete anonymity of the GUID, then yeah, sequential GUIDs will work. Just the one thing you have to think about is overinflating your index footprint. If you've got a clustered index, just keep in mind that GUIDs take up more space than regular integers do. Question here about no lock. You got to be careful around that. That will introduce dirty reads, basically transactions that are kind of half-baked. So just be careful when you're using that. Supposedly, no lock is supposed to be a deprecated feature anyway. So if you are doing some analytics on data and you want to do a query that is not going to block anybody, and you just want to do one quick and dirty, no lock is okay. I prefer just setting the transaction isolation level to read uncommitted. It achieves the same thing, and you don't have to do the lock on every from and every join clause that you need to do. So that's just a tip. DBAs require every single view to utilize the no lock hint. Okay, interesting. Yeah, if it truly gets deprecated, they've been saying it for years though. But a lot of code bases are going to have a bad day when that does happen. So you know how it is. Yeah, it's going to be deprecated, but it's still around.
There's also the read committed snapshot isolation level, same level of concurrency as read committed, but implemented differently. So you're not taking
Absolutely.
out logs, you just take on the eventual consistency trade-off, as opposed to Microsoft chose the default of read committed because they really emphasized the C in ACID.
Yes.
Being strongly consistent. Oracle, I think, chose RCSI as their default. So you still get the same level of consistency. You just kind of take on that eventual consistent model.
Yep, that's accurate.
Any other questions out there?
Well, it was great talking to you guys this evening.
Well, thank you, Preston. That was very helpful. I think I learned a few things myself, and I already
Good.
Earlier in the week, so you held back on us. So.
Good, great. That was the goal. I want everybody to grab one idea out of this.
Very nice. So I'm assuming you can get me the slide deck so we can share that with the group shortly afterwards. And like I said, I was taping the presentation, so I'll be loading that up to YouTube tonight, and I'll post a link to the Meetup channel for this session, so everybody can have it and use it. But outside of that, just thank you all for joining us tonight, and I'm glad you could come out. Like I said, we've got a few great talks lined up for the months ahead, so please go ahead and opt in for those, and I will let you know what our November slate looks like when we get there. So outside of that, I hope everybody has a good week and weekend, and look forward to seeing you all next time. So thank you. Thank you, Preston.
Thanks, guys. Really appreciate it. Good meeting you guys.